So here's a quick overview of the execution reification system that we built for the Lively project a while ago. Over here on the left side you see a function that counts up to 4, and in each step it prints the counter, and at 3 it hits a breakpoint. So what happens when we define that function and we run it? You will see over here on the right side it goes up to 2, and then the execution stopped. And what happens when we call that function using that stack reification run method is that we internally create a continuation. Basically, we capture the entire stack that is being created, and when we hit the debugger point, we stopped and stored all the stack state of that function, and basically all calling functions that were there. And we look at the actual state that was being captured. We see that there is a current frame object, which is sort of the executed frame, and that current frame has a scope object, and we look inside the scope, look at the mapping. We see, for example, the counter variable here, that is 3. Now, if we have the actual execution as an object, we can do all sorts of things with it. So on the one hand, we can serialize it. We can copy that execution. So let's copy that, clear the log. We can resume the original execution here. We see it counts to 4 again, but we can also go to the copied execution and we can run it again, and we will see it will execute sort of this part again. You can basically send this kind of execution object to a different JavaScript VM, a different browser context or server context, and basically continue the execution in that way. Short overview over how that works. When we look what happened with that function that we had here, the essence is that we rewrite the source code of that function. So when we look at the rewritten version, we will see that it looks quite unlike the original source code. What we do here is we basically wrap each statement and we capture sort of the program counter. This means where we are in the execution of that function. And the debugger statement actually was translated into a throw. So we basically throw an exception here that unwinds the stack, and each of the in the local state and each of the program counters, especially the program counter that we are currently at, is part of the state that gets unwound and then basically caught by the stack reification run method, which then creates the continuation object. And when we look at the graph itself, we will see that for example, in our case, we stopped at the AST index 13. When we look at that, it's the debugger statement that we have over here, and when we want to resume the execution, we can sort of just jump ahead to the statement, and we then basically insert all the captured state that we had before, that sort of part of that skipping over, and at the point of the debugger we can continue the execution here, sort of following the AST and yeah, resuming that. So this is just like a short overview of that. Apart from basically externalizing the computations that are involved, you can also easily create a debugger with that, which was one of the goals of the project. All right.